Hello everyone, welcome to today's class. In this lecture, we are going to discuss another method of integration, that's by parts. Okay. Now, let's look at the format actually first. It is applicable on UV. Suppose two functions are being multiplied. Most of the time we have used substitution for this, but suppose they are absolutely different kind of function. One is algebraic multiplied by trigo, log multiplied by trigo, log multiplied by algebra, exponential function multiplied by this. So those kinds of questions will be done easily through by parts. That's the way to identify. Plus, it's your last resort to solve any problem. First, try substitution. If that doesn't work, then last option is by parts. Okay. So suppose you have two functions uv. Okay, first function, second function. Okay. So what you do in this, you do first function, you keep it as it is. Okay. Integration of second function. Okay, like this, minus integration of the second function, differentiation of first function, like this. So keep it like this, first function as it is, integration of second function, minus integration of second, means this is same, whatever is present here will be written first, and the first function that we kept as it is multiplied by the differentiation of that. Okay. All right, let's start by looking at few examples of it. First question. Find x e raised to power x integration. You can see this is algebraic function, polynomial basically. This is exponential, e is there. Now, of course, we have to apply by parts. So you have to take something as the first function, something as the second function. Now, what do? There is a priority order that you need to follow. It's called I late. Means what will be your first function? This is this priority list. First is inverse functions, basically your inverse trigo. Then second priority is for log. Third is for algebra. T is for trigo. And E is for exponential. Means exponential is the last thing that you have to consider as the first function. So algebra comes first before the exponential. So this is our first function, this is our second function. Okay. Okay. So this integration is first function as it is. So 1 x is as it is, integration of e की power x minus, or you can call this as uv if you want to use the formula exactly, but my suggestion, learn it in form of a language. Okay, first function as it is, integration of second function minus integration of second function, differentiation of first function. Okay. Now let's now I'm not writing dx, but of course whenever integration is there is supposed to be a dx. Okay, so for simplicity I'm not writing. So x e raised to power x is, integration is e raised to power x minus integration, again same thing, whatever result came here we'll write it here, e raised to power x, differentiation of x is 1, and now you integrate this, x e raised to power x minus e raised to power x, integration is e raised to power x, and of course plus c. All right, so as such by parts is an easy method as long as you know what's your first function, what's your second function. Next question. Integration of only log x is there. So first of all, we know that if we integrate 1 by x we get log x, but so far we have seen a lot of formulas, none of the formulas was directly relating log x, because there is no such integration directly present for log x. So what do we do with this? And also, even if you want to apply by parts, there are supposed to be two things. Two things are not present here. So I'll modify this as 1 into log x, okay, because 1 can be multiplied with anything. Consider now as your priority I late inverse, and then L is for log. So this is your first function, this is your second function. So first function as it is, integration of second function, okay, 1 dx minus integration of integration 1 dx differentiation of log x, second function. So log x, integration of 1 is x minus integration of x into log x differentiation is 1 by x. Again it cancels. So this is basically x log x minus integration of 1, again dx should be written. So 1 integration is again x and plus c. All right, done. Next question. X sine inverse x square root of 1 minus x square. Okay. Three functions are present, denominator is also present. So I cannot directly apply by parts. It will be very typical. So what I'll do is, if you look at this carefully, 1 minus x square sine inverse x, you know sine inverse x differentiation is this, na? So why don't we use that? So let's do a substitution first. Let sine inverse x as t. So 1 upon square root 1 minus x square dx is dt. Okay. This whole thing becomes dt. So your integration is actually sine inverse dt. Sine inverse x is t. Now what is x? If sine inverse x is t, what is x? Sine t. So the question becomes sine t into t. So basically I'll write it like this: t sine t dt. Okay. Again use ILATE, ILA. Algebra comes first. So take this as the first function, take this as the second function. So first function as it is, integration of second function minus integration of same integration that we have written, differentiation of the first function. Now this time everything is in terms of t, so integration is also with respect to dt. Okay. So t, integration of sine t is minus cos t minus, again this my integration will result in minus cos t, so it will become plus, I can take negative outside, cos t, and differentiation of t is 1 dt. So minus t cos t plus cos t integration is sine t plus c. And what was t actually? T was sine inverse x. Okay. So minus t cos of bracket sine inverse t plus sine of sine inverse t plus c. Sorry, not t, x actually, it was x. So sine of sine inverse x, inverse and sine will cancel each other, but we cannot cancel this. So we can convert, how to convert sine into cos, sine inverse to a cos inverse. we know now, sine inverse x is basically some theta. So basically x is sine theta, x upon 1. Let's assume a triangle, theta, perpendicular is x, 1 is this hypotenuse, perpendicular upon hypotenuse. So this will be 1 minus x square. Now we want cos inverse because I want to cancel this cos. So what we'll do is write cos inverse, let's write cos theta first. So cos theta is base upon this. So base is square root of 1 minus x square upon 1. So theta is cos inverse square root 1 minus x square. You can put it here. So minus t cos bracket cos inverse square root of 1 minus x square, okay, plus x plus c. So now cos and cos inverse also cancel. So minus t, sorry, I forgot to change the t. Let's change this t also. So t was sine inverse x. So sine inverse x multiplied by this cancels. So square root of 1 minus x square plus x plus c. That's the answer. All right. Next, there is one particular kind of problem. See this one. E raised to power x sine x. Okay. So our integration is integration e raised to power x sine x. Isolate. Inverse is not there, log is not there, algebra is not there, t, trigonometry. So this is our first function, this is our second function. So this becomes first function as it is sine x. Let's write here I is equal to sine x as it is, integration of e power x, then e raised to power x integration again, and differentiation of sine x. Okay. So this becomes sine x into e raised to power x minus integration of e raised to power x into sine x differentiation is cos x. Still this cannot be solved, so again applying by parts on it. Same thing, first function, second function. So e raised to power x sine x minus integration of this first function as it is, integration of e raised to power x, now I'm writing direct, e raised to power x minus integration of, again same integration, e raised to power x into differentiation of cos x, that's minus sine x. Okay, I've applied by parts here. Okay, so this integration is e raised to power x sine x minus e raised to power x cos x plus why it is coming plus, should have been minus, why is this coming plus? I have taken sine x as the first function. Still sine x differentiation is cos x as it is. Okay, correct now. So it's not plus. This negative negative cancels, so it is plus, and there is a negative outside this bracket now. That makes it negative. Minus integration e raised to power x sin x dx. Now if you look at the question itself was this. So this is nothing but I is equal to e raised to power x. If I take common in from these two, e raised to power x sin x minus cos x minus I. This is I again. So take this on the other side. So 2i is e raised to power x sin x minus cos x. So I is e raised to power x sin x minus cos x by 2. So in a true sense, we never really integrated this because it again generated the integration itself. So this keeps on going. So there is no sense of applying by parts again. So I've written this as I again and take it to the other side. Okay. All right. Then there is a type of form in which what happens is one second. A special form as such, integral of type this. Now this form is very interesting because if suppose a question is there where e raised to power x is there and fx plus f dash x is there inside it, the answer is very simple, e raised to power x fx plus c. And how do we get that? You apply by part on this, only on this part. Somehow that generates another two terms, it generates by parts. So that term somehow cancels this one. And effectively you are left with only e raised to power x fx. So what you have to learn is, if suppose there is a function type of integration in which you have a function like e raised to power x and inside I can write fx plus f dash x. I don't have to solve anything. I'll write direct answer e raised to power x fx plus c. Okay. Let's look at some questions based on this format. Look at this question. Again, one step question, not a typical one. E raised to power x is there. This is your fx. Interestingly, this is your f dash x. Tan inverse x differentiation is 1 upon 1 plus x square. So I can say the direct answer is e raised to power x fx plus c. So what is our fx? Tan inverse x plus c directly. One step question as long as you know the format. Not every time you will get a spoon feeded question. Okay, this time e raised to power x is there, but look at this. I'll easily identify where is fx, where is f dash x. Let's try to break it. E raised to power x integration. What I'm doing is, in order to break that, x square plus 1, but there is x plus 1 whole square. So what I'm going to do is one adjustment. I'm writing 1 as minus 1 plus 2. Okay, I can rewrite that, and I'm splitting like this, x plus 1 whole square upon x plus 1 whole square. You'll see why. Okay, now integration e raised to power x. What is x square minus 1? X plus 1 x minus 1. So that cancels 1 x plus 1 from the denominator. So this becomes x minus 1 upon x plus 1 minus 2 upon x plus 1 whole square. Okay. Now, it's not necessary that every time inside whatever is written e raised to power, whatever inside is written, two parts, the first one has to be fx, second one has to be f dash x. No. there is a possibility that reverse can also happen. First f dash x is written and then fx is written. So the only problem is to identify either this is your fx or this is your fx. Okay, if suppose this is my fx, so if I differentiate this again, so x plus 1 power minus 2 is there basically. So what is the differentiation? It will become minus 3. There is no minus 3 present here, so this cannot be fx. So the good possibility is this could be fx. If this is your fx, check your f dash x. F dash x will be, let's check it here in the separate part. Denominator, this is u by v, so x plus 1 whole square. Then u dash v, u is this, so 1 into x plus 1 minus v dash, denominator differentiation again 1 x minus 1. If we solve this, what do we get? 2 upon x plus 1 whole square, which is present. So now I can say if this is my fx, this is my f dash x, and this is satisfying the format. Okay, so my answer directly e raised to power x, x minus 1, x plus 1 plus c. Simple format, good application, quick one. Okay, all right, that was mostly about by parts. Most of the questions are of this format effectively. Log as we have integrated, you can integrate similarly. So if there is a single function like log x was there, na? So what did we do with that? We multiplied 1 with it and then we took first function, second function. Okay, so you can questions the practice of, you can practice the question of NCERT directly. They're not very typical, it's pretty much straightforward. Okay, we are going to discuss more questions on this format, e raised to power fx plus f dash x, because those are slightly typical. All right, let's take a look at these questions. One, two, three. Okay, let's look at this first question here, 16th one. This is again integration we have to do for everything, and e raised to power x sin x plus cos x. Clearly, if this is my fx, sin x differentiation is cos x. So I think that satisfies the format. Answer in one step, e raised to power x sin x fx plus c. However, for this question, okay, the first one was very simple. For this one, you'll have to slightly adjust. It's not simple enough. So e raised to power x, this is x. Okay, but what I'm going to do the adjustment as, mostly we have seen, we try to adjust with the denominator. Let's try to generate x plus 1. So plus 1 minus 1. Okay, and then I'm writing x plus 1 whole square, x plus 1 whole square separately in two parts. So this is basically e raised to power x integration 1 upon x plus 1 minus 1 upon x plus 1 whole square. Okay, so this is integration e raised to power x. I don't have to do anything. See, 1 upon x plus 1 differentiation is minus 1 upon x plus 1 whole square. This is very understandable. Okay, so format is satisfied. Answer is e raised to power x upon x plus 1 plus c. The last one, we'll have to see about that. Okay, short questions will be based mostly around this. Okay, all right. Numerator has 1 plus sine, denominator has 1 plus cos. What can you do about 1 plus cos? What can you do about this 1 minus sine. By adding plus 1 minus 1, again you cannot do anything. But 1 plus cos, we know 1 plus cos is something. Let's try that if that works. E raised to power x. What is 1 plus cos? Just I think we are at the end of indefinite integral. So should be knowing this. Trigonometry, we have done a lot of questions based on this. 1 plus cos is 2 cos square half of the angle. Okay. And 1 plus sine x. Remember, if we break this into sine square x by 2 plus cos square x by 2. Okay, sine x by 2 cos square 2 whole square plus sine x, I break it like 2 sine x by 2 cos x by 2. Okay, so what I've done, I've broken 1 as sine square plus cos square. I have broken sine x as 2 sine x by 2 cos x by 2. Denominator, you know the property. So this becomes what? E raised to power x. Numerator becomes sine x by 2 plus cos x by 2 whole square, and denominator is integration is going on 2 cos square. So I can take cos also inside this. Okay, so basically, and now 2 in the denominator, so I'm writing 1 by 2 outwards. E raised to power x, this is nothing but 1 plus tan x by 2 whole square. Okay, so what if we open this integration e raised to power x, let's get some space. 1 plus tan x by 2 na, so 1 square 1 plus tan square x by 2 plus 2 tan x by 2, still nothing. 1 plus tan square is sec square, so finally we have two terms, sec square x by 2 plus 2 tan x by 2. Now you have to decide which is your fx and which is your f dash x. If you take this as fx, usually so far we have done the question in which most of the time first function was fx, second was f dash x. What is the differentiation of sec square? Definitely not tan x by 2. That's the integration of sec square. So that means if I take this as my fx, 2 tan x by 2 differentiated, 2 multiplied by tan square differentiation is sec, and then x by 2 differentiation 1 by 2. So you will get this as f dash x. Okay, so what does that become? 1 by 2 integration, this is fx plus f dash x, so directly e raised to power x, fx is 2 tan x by 2, so 2 tan x by 2 plus c, so 2 cancels, basically e raised to power tan x by 2 plus c. Okay, good question. Somehow I didn't expect this much. All right, 1 second. 2 more questions, easy ones. I think this is again very simple. 1 by x differentiation is minus 1 by x square. So done. Answer is e raised to power x. 1 by x means e raised to power x by x plus c. With this, you'll have to see the adjustment because this is not written in form of e raised to power x fx plus f dash x. So let's adjust. So is equal to integration e raised to power x. X minus 3 is there, na? And denominator is x minus 1. So far we have seen, we try to generate denominator and things automatically happen. So x minus 1 minus 2. Okay, minus x minus 1 whole cube, x minus 1 whole cube. Okay, I've broken this as this and this, and then separated in 2 parts. Dx So integration e raised to power, this cancels one power, so e raised to power x 1 upon x minus 1 whole square minus 2 upon x minus 1 whole cube. Okay, so clearly x 1 upon x minus 1 whole square is differentiated, take it to in the numerator, power minus 2, power minus 2 comes down, so negative 2 is here, and minus 2 minus 1 minus 3, yeah, working. Take this as fx, this is your f dash x. So I think after that, that's the only setting required. You have to create fx plus f dash x, that's it. E raised to power x upon x minus 1 whole square plus c. So, all right, we are done. That was all about by parts. Now one exercise I'm going to do, that is again with standard results, but I think the idea was slightly missed in that. 1 second, let me get the formulas, because the rest everything is same in this standard results. Now we have already done the questions on this standard results. This is an additional part of standard results. The remaining 3 results, they are lengthy, but I'll teach you a method to learn them, memorize them easily. Indefinite we have done by parts. I'm adding this in by parts lecture only. Okay, so you'll find the notes of this in this order only. After by parts you'll find this, but again try to think this is directly related with your standard results. Let's add it there, otherwise it will create confusion. We have done the standard results now. Okay, so for these formulas, again these are also modified results, but I prefer them in standard results effectively. The only difference is, if this was in denominator, the answer would have been sine inverse x by a. This is in the numerator, so you have a big result. Same thing, this is in the denominator, you will have the answer as log of this, you know this. And same thing, if this was in the denominator, then you will have the answer of this log. This additional part is very simple. What do you do? Like first integration, just put x by 2 with it, copy remain the same, x by 2 same thing, plus 1 by 2 a square, 1 by 2 a square is always there, plus 1 by 2 a square plus 1 by 2 a square. It's just that with this last one, be slightly careful, this is minus 1 by 2 a square. Okay, and then do the think of the integration of 1 upon a square minus x square, that was sine inverse x by a square plus x square, that was log of x plus square root of x square plus a square. X square minus a square was log x plus square root of x square minus a square. Okay, so x by 2 with the first with the same numerator, plus half of a square into, if it was in the denominator, apart from the last one. So be careful with this negative sign, that's it. And the ideas are all exactly same, not almost same, exactly same. There is nothing typical about this. Okay, I'll discuss few questions, they are very easy. The first one, you have to integrate this. Okay, so clearly this is a square minus x square, so a is 2. Okay, now let's write the answer. What do? First of all, x by 2 with the same numerator, square root of 4 minus x square, plus half of a square. A is 2, a square is 4. Then sine inverse, this is a square minus x square, so sine inverse x by a, x is x, a is 2, plus c, as simple as that. So it's just a format that you have to learn, and don't try to learn in like formula wise, go learning each and every expression. Try to learn it like this: 1 by 2 same numerator, half a square if the integration of its reciprocal. Second one, same thing, again this time a is this, and let's consider this as capital X. Okay, so this is if I want, I'll rewrite this as integration square root 1 square minus 2x whole square. Okay, now compare it with a square minus x square. I'm writing capital X just to avoid the confusion. Now what is the answer? The answer is x by 2, but remember which x. This is where the problem comes. Capital X, not the small x. Capital X is actually, I'll write this is the first question of this sort, so I'm writing capital X. Let's write the identity in capital X first of all. Capital X square root of this is 1 minus x square, so square root of a square minus capital X square plus 1 by 2 a square sine inverse capital X by a plus c, of course. Now replace your capital X with 2x actually, because it was 2x. Square root of same numerator, that's 1 minus 4x square, okay, plus 1 by 2, what's our a? 1, so 1 square is 1, and sine inverse capital X is actually 2x, so 2x and a is 1. But there is a problem. What? The coefficient of x is still 2. That means your whole answer will be additionally divided by 1 by 2. That's a very crucial part. That is nothing to do with this identity. That's the concept of ax plus b. If you have ax plus b format, 1 by a additionally comes, and it comes with the both results. Don't think that it will come here or here. No, with the both results additionally. Okay, so in that scenario this gets modified to x square root of 1 minus 4x square plus 1 by 4 sine inverse 2x plus c. Remember, this is very crucial, very casual mistake. We are at the end of indefinite integral and still that ax plus b format is being continued. So don't get too casual with this integration. Just because you know the format doesn't mean you will not carry forward the ax plus b format. That's still applicable, and that's why I personally like the second question. Okay, the moment I usually ask the same question in the exam, most of the students have the tendency to skip that factor of 1 by 2. Okay, and what if the MCQ question is there and they have two options, one with without 1 by 2 as a factor, then second one is with 1 by 2 factor. If you're getting your answer, you'll take the first one by default. You'll forget about this 1 by 2. Okay, all right, let's deal I like this one. Let's deal with this one also. Okay, because these questions are very easy because they are based on direct formats. Okay. Third, integration of this. So if we rewrite this first of all as integration, this is question number 3, not 3 as such. Okay, I'll remove this 3. So this is 1 plus x by 3 whole square square root. Okay, this is a square plus capital X square. So write your identity in capital X and then replace your capital X by x by 3. I'm comfortable, so I'm writing directly. Okay, first is capital X by 2. Okay, so capital X is actually x by 3 and another 2 of it. Okay, into same square root 1 plus x square by 9 plus, then comes half a square 1 by 2, a is 1. Okay, so 1 square is 1. Then comes log of, if this was in denominator, the answer would have been log x or capital X, which is x by 3 plus same square root 1 plus x square by 9 plus c, of course. And the casual mistake that happens, because of this 3 as a coefficient of x, that will come in division. So additionally divide by 1 by 3. Divide by 1 by 3. 1 upon 1 by 3, that means multiply by 1. Okay. Or you could have avoided this also, but you know, if you would have taken the LCM, this would have been the other approach. This is a direct approach, or you could have done, in which this problem doesn't be an issue. That will be if you write this as 9 plus x square, and denominator square root 9 is 3. So you take this 3 out of the integration. Now you don't have the problem of coefficient of x. You can do by that method also, but it depends how the question is, if this is the MCQ question, and how the answer is given, whether they have given in this format or this format. Okay. So always read your options before solving any question for MCQs. Okay. Now one last problem. Okay. What if they don't give you the direct format? What if they have this? What is this? This is like square root of a quadratic equation. So far we did in standard results is that 1 upon square root of quadratic, 1 upon quadratic. But what was the whole idea? If only quadratic is present, what do? You do make perfect square, na? You create perfect square. So same thing will be followed here also. Integration, this is, if I try to make it perfect square, it's very easy as such. 2x plus, I can write this as x square plus 2x plus 1 plus 4. Okay, you can use that method, adding 2 square, adding 1 square, half of this, na, divided by 2, then adding 1 square, subtracting 1 square, that will also work. This was an easy expression, so I identified it easily. So x square plus 2x plus 1 plus 4 I've written. So this becomes integration of square root of x plus 1 whole square plus 2 square. Now that's your capital X. This is your a square, x square, a square. So the answer is capital X by 2, which is x plus 1 by 2, x by 2 into square root of same expression. Same expression means this one, and this gets simplified to this. Okay, x plus 1 whole square plus 2 square, same expression, plus 1 by 2 a square. A is 2 square, which is 4. Then comes log, then again capital X and capital X square plus a square. Capital X is x plus 1 plus square root of x plus 1 whole square plus 4 plus c. The answer is only lengthy, that's it, nothing else. Integration point of view, they are very simple. So this is again nothing but, if we simplify this, we get the original question, that is x square plus 2x plus 5 plus this becomes 2 log, this should be in mod, okay, mod x plus 1 plus square root of, again this is x square plus 2x plus 5 plus c. That's your answer. All right, additional part of standard results is also done. That pretty much take care of your indefinite integral. Okay, that's it for this lecture. See you in the next class. Good day everyone.